Swayam Prabha. Digital India. Educated India.
Welcome to Lecture 5, Numerical Problems, Part 2. I will be continuing the problem from where I have stopped in the previous lecture. So, before continuing the problem, let us see the question which was asked. So, for an evaporator temperature of minus 18, condenser temperature of 32, the mass flow of the refrigerant is given 0.05, which is same for all the three problems which we have solved so far. We have to find out the evaporator heat load, that is QE, power required to drive the compressor, that is power input, work of compression WCO, rate of heat rejection QC, and the COP of the refrigerator. And the condition the refrigerant in the problem which we are solving is dry and saturated at the inlet of the compressor. So we have calculated up to this the superheated enthalpy. I stopped up to this point in the previous lecture, so we will be continuing this one. So to calculate the superheated enthalpy, we use this formula H2 equal to H2 dash plus Cp of vapor into delta T. Delta T is T2 minus T2 dash. And the calculated value was around 424.06 kilojoule per kg. 424.06 kilojoule per kg. Now, if you look at the TS diagram, so we have already calculated H1, H2. The only remaining enthalpy to be found out is H3, which will be equal to H4, State point 3 is lying on the saturated liquid line. So, similar to the previous two problems, H3 value will be equal to liquid enthalpy corresponding to condenser temperature. So, let us move to state 3. State 3. So, enthalpy at 3 is equal to liquid enthalpy at T3 is equal to T2 dash is equal to Tc is equal to 32 degree centigrade. Okay, from R134A table. So, let us go back to the table. So, this is 32 degree centigrade. Enthalpy of liquid is this one. So, 244 point. It is the same value which we have taken for the previous two numerical questions. 244.55. H3 is equal to 244.55 kilojoule per kg. This is equal to H4. Let me remind one thing at this point once again. If you want to calculate the superheated enthalpy, the formula is, you don't have to mug up the formula, it is saturated enthalpy plus Cp of vapor, because the condition of refrigerant at state point 2 is vapor, into delta T. Delta T is T2 minus T2 dash. And Cp of vapor, once we find the temperature T2, so T2 dash is given, that is the condenser temperature, which is equal to T3. So we have to take the Cp value for the average of the temperature T2 and T2 dash. Now let us calculate one by one. The first one is evaporator heat load. So m dot R into H1 minus H4. Since there is change in the enthalpy value H1, so obviously, though there is no change in the state point 4 enthalpy value, there will be change in the evaporator heat load. And here, again, as I have told before, it should be m dot r, m dot r. So wherever flow rate is given, it is m dot r. Okay. So it is m dot r. I think here and all is fine. So QE value comes to 7.17 kilowatt. If you substitute the values and calculate, 7.17 kilowatt. Okay. Next, work of compression, that is m dot r into compression is process 1 to 2, so H2 minus H1. So if you substitute the value H2, we have in the previous lecture, towards the fag end of the lecture, the H2 was calculated. So again, I have mentioned that value here also. So this is H2. H1 is already found. So if you see the work of compression, it comes to around 1.8 kilowatt, 1.81 kilowatt. 1.81 kilowatt. Second question is, we have to find out the condenser heat load. So m dot r into, so if you see the diagram, 1 to 2 is isentropic compression. Condensation, we have to take the state point from 2 to 3. So this is 2 dash. Just for our reference, we have taken 2 dash. This is 2 dash. Okay. So H2 minus H3. 8.98 kilowatt. If you calculate, substituting the enthalpy values, H2 minus H3, H3 equal to H4. Now the COP of the system. Since QE and W work of compression has changed, there will be change in the COP of the refrigerator also. So QE by work of compression. So if you calculate, the COP comes to 3.96. 3.96. And the energy balance, let us do the energy balance. QE plus WCO is equal to, QE is 7.17 plus WCO is 1.81. It comes to 8.98 kilowatt, which is equal to heat rejection by the condenser. So this is the energy balance. Okay, so it's perfectly coming. So with this, I conclude this lecture. Thank you.